Hey everyone, today we are going to look at some linear inequalities from word problems. So we are using a situation and we're going to set up a system of inequalities using the variables that are presented to us in the situation. So first thing we're going to do, we're going to read through the problem. I'm going to highlight some of the important words and we're going to talk about the symbols that we should use to represent each of those phrases. So Joshua and his children went into a grocery store and will buy bananas and peaches. So right off the bat, I'm highlighting bananas and peaches because those are the two items that I am dealing with. Each banana costs 70 cents and each peach costs $2. Joshua had a total of $25 to spend. Let me actually make that highlighter a little smaller so we can see. Had a total of $25 to spend. And we want to write an inequality that would represent the possible values for the number of bananas purchased and the number of peaches purchased. So basically what we're saying is we want to just write an inequality that tells us how much what are the possible numbers of bananas we could purchase and peaches with that stipulation that we have $25 and bananas and peaches have a specific cost. So the first thing we want to do is we always want to come up with our labels. So we're going to say that B is equal to bananas. We're going to say P is equal to peaches. So we have our two variables. And then we want to talk about what this total of $25 means. So if we think of this as a budget, we think that we can't spend more than $25. So the inequality that I want to use is less than or equal to $25 because the cost of these should be less than or equal to $25. So now, sorry, I got ahead of myself. So now we are going to set up our inequality for the cost. So the cost of each banana is 70 cents. So we are going to write 0.70 times B. And to that we are adding 2 times P. So this is saying this is our bananas cost 70 cents and our peaches cost $2. If I add that cost together, the sum should be less than or equal to $25. So our inequality is 0.7 B plus 2P, and that is less than or equal to 25. Okay, let's do one more. Sarah is working 2 summer jobs, making $7 per hour babysitting. So $7 per hour babysitting and $20 per hour lifeguarding. So already we have our two variables. We're going to say B is equal to babysitting and we're going to say that L is equal to lifeguarding. Sarah must earn at least $110 this week. At least $110. Write an inequality that would represent the possible values for the number of hours babysitting and the number of hours lifeguarding that Sarah can work in a given week. So, the other thing that I should add is babysitting hours. And this is lifeguarding hours. All right. Our inequality here is pretty clear because they tell us that is at least. So we need to be greater than or equal to 110, since I want to be, I want values that are bigger than 110, but at least $110. And so my babysitting hours, this is going to be 7 times B plus 20 times L, that is greater than or equal to 110. So 7B plus 20L is greater than or equal to 110. Okay, so far so good. We're just kind of setting up our inequalities, but now we're going to look at some systems where we have more than just one situation. So these were inequalities where we just had one thing going on. Here we just had the cost of the peaches. Here we just had number of hours worked. Okay, so now we're going to look at some situations where there's more than one thing going on. And part of this question, the only part of this question that we're going to focus on, we're just going to focus on writing our, we're just going to focus on writing our system, okay? So I'm not going to worry about the second part of that question. An online furniture store sells chairs for $50 each. So we have chairs for $50, and we have tables for $250 each. Every day, the store can ship no more than 36 pieces of furniture and must sell at least, wow, sorry everyone. Let me get back to my notes here. At least $3,400 worth of chairs and tables. So let's do $3,400. So we're going to have two equations here. So let's start with our variables. We'll say C is equal to number of chairs and T is equal to number of tables. Okay. So let's start with cost. We'll start with the cost, and we're going to set up an inequality that represents the amount sold, like the amount in dollars sold. So chairs are $50 each, so I'm going to set up my inequality, 50 times C, and tables are $250 each, so 250 T. And here's what we said. We said that we have to sell at least $3,400 worth of chairs and tables at least. So this phrase, at least, means I want to sell greater than or equal to $3,400. So there's my inequality. 50C plus 250T is greater than or equal to $3,400. We also want to come up with an inequality for amount of items. Like how many things are we selling? And so the store can ship no more than 36 pieces of furniture. So if 36 is the max, then I want less than or equal to 36. So let's come up with an inequality there. So chairs, the number of chairs, plus the number of tables is going to be less than or equal to 36. So now my system is 50C plus 250T is greater than or equal to 3,400, and C plus t is less than or equal to 36. All right, so I'm going to go look at the next problem. I want you to pause this problem, try it on your own, and then once you have tried it, go ahead and unpause and see if you got the right answer. So again, I'm not going to worry about this part of the question. We're just going to worry about setting up our system. So Daniel is working 2 summer jobs, making $8 per hour babysitting, $15 per hour lifeguarding. In a given week, he can work a maximum of 18 total hours and must earn no less than $200. So at this point, I'd like you to pause. We're going to set up a system for his amount, like the dollars he makes. That was a weird way to say that. Dollars, how much he makes, and then hours. Okay, so go ahead and pause. All right, now that you have unpaused, let's start with our hours. So if he can work a maximum of 18 total hours, so we need to set up our variables. So we're going to say B is babysitting hours. And L is lifeguarding hours. Then, if I can only work a maximum of 18 total hours, then that means my babysitting hours, or his babysitting hours, plus his lifeguarding hours have to be less than or equal to 18. So this maximum we should choose less than or equal to 18. And let's talk about how much he makes. So if he is making $8 per hour babysitting, then this becomes 8 times B. And we are adding to that 15 times L. And if he can earn no less than 200, no less means I want greater than or equal to $200. So greater than or equal to 200. And so my system becomes B plus L is less than or equal to 18. 8B plus 15L is greater than or equal to 200. All right, so after this, you are heading to Delta Math to do some practice, and this is to let me know that you are present today.